Good afternoon. Welcome to NASA headquarters. My name is Dwayne Brown with the Office of Communications. Today, you will hear about final preparations and ongoing mission activities for the scheduled September 21 Mars orbit insertion of NASA's Mars Atmosphere and Volatile Evolution, or MAVEN spacecraft. We'll have brief presentations and then open up for questions on our phone lines and our social media. Before we start with the presentations, to set the stage for the mission and its role in NASA's overall planetary activities, please welcome Jim Green, Director of NASA's Planetary Science Division.
Thank you very much, Dwayne. You know, MAVEN has a critical event this weekend. I don't know about you, but I'm sure this is true of the panelists. I'm all on pins and needles. This is a critical event, and we're all pointing towards a successful insertion of orbit. MAVEN is arriving at Mars at a time when we have a number of missions there now. This is our next big step on our journey to Mars. You know, for humans to go to Mars, it's not like Star Trek. It's not like go where no man has gone before. It's really the planetary scientists that are blazing the trail for us to understand everything about Mars that we need to for humans to be able to land safely on Mars and explore and journey around the planet. This is an exciting time. MAVEN is just, as I mentioned, part of our fleet. We have several NASA orbiting spacecraft and, of course, the very famous Curiosity and Opportunity on the surface roving around. MAVEN fits a unique niche. We've needed to know a number of things that MAVEN is going to discover for many, many years, and now I'm excited to see that it's going to become a reality. So without further ado, let's get on with the show and find out what's happening with MAVEN. Let me turn it back to Dwayne.
Thank you, Jim. Of course, there's a lot of conversation on social media, and for those who are watching, send your questions in to hashtag AskNASA, join the conversation, and learn more about what's going on as we go back to Mars and continue the journey to Mars. Also, updated on the information on this briefing and the latest developments for the orbit insertion, go to www.nasa.gov/MAVEN. Well, ladies and gentlemen, you know, this mission is going very well, and you'll hear more about that later. And I think for my biggest challenge is going to be making sure I pronounce the team's names correctly. But they promised me they wouldn't put me in timeout if I got it wrong, but we're gonna get started, and they're gonna help me out here. The Team MAVEN participants are Lisa May, Lead Program Executive, Mars Exploration Program, NASA Headquarters, Washington. Bruce Jakowski, MAVEN Principal Investigator, Laboratory for Atmospheric and Space Physics, University of Colorado, Boulder. David Mitchell, MAVEN Project Manager, NASA's Goddard Space Flight Center, Greenbelt, Maryland. And Guy Budelshees, Lockheed Martin, MAVEN Program Manager, the Lockheed Martin Space Systems Company in Littleton, Colorado. And with that, I'll toss it to Lisa to kick us off.
Thank you, Dwayne. Hello, everyone, and welcome to the MAVEN pre-Mars orbit insertion press event here. As part of NASA's journey to Mars, the Mars Exploration Program itself is a discovery-driven science program. Its missions are all linked not only by science, but also by technology advances and providing infrastructure for other missions, such as orbiters providing data relay for surface missions. In this graphic, we see current and upcoming missions to Mars, both ours here at NASA and those of our international partners to which NASA has made significant contributions. Soon, Mars Reconnaissance Orbiter, Odyssey, and the European Space Agency Mars Express will be joined by MAVEN in Mars orbit. And not long after that, they'll also be joined by the Indian Space Research Organization's MOM mission, only a few days later. MAVEN is part of NASA's overall Mars exploration strategy. It is the first NASA mission dedicated to studying Mars' upper atmosphere, science that was called out in our very first planetary decadal survey, as well as having been part of the heliophysics roadmap. It will build on atmospheric measurements made by Curiosity, Mars Reconnaissance Orbiter, and Mars Global Surveyor to explore Mars climate history. Like Odyssey, Mars Express, and Mars Reconnaissance Orbiter, the upcoming European ExoMars Orbiter in 2016, MAVEN also carries a communications payload to provide relay services for surface missions after its primary science mission is done. MAVEN continues to be a tremendously successful partnership between universities, industry, and the government, NASA. The team, University of Colorado, Goddard Space Flight Center, Lockheed Martin, Berkeley, Jet Propulsion Laboratory, Launch Services Program, and the United Launch Alliance have hit all of their marks exactly as proposed to NASA back in 2008. They are on schedule, and they're ready to get to work at Mars. We're very excited about MAVEN's arrival and their transition to science operations and solving the mystery of what happened to Mars' atmosphere. To tell you how MAVEN will solve that mystery and make other science discoveries, I now give you Dr. Bruce Jakosky.
Thank you, Lisa. The MAVEN mission is about understanding the history of the climate on Mars. We're going to be exploring an aspect of the Martian atmosphere and upper atmosphere that really has not been explored in detail by any spacecraft to date. If we can go to that first graphic, the evidence shows that the Mars atmosphere today is a cold, dry environment, one where liquid water really can't exist in a stable state. But it also tells us when we look at older surfaces that the ancient surfaces had liquid water flowing over it, shown in this video. And we see evidence for lakes, for river channels, a lot of evidence for liquid water that required a very different climate than the one we have today. What that leads us to ask is, where did the water go? Where did the CO2 go from that early environment? And it can go to two places. It can go down into the crust, or it can go up to the top of the atmosphere where it can be lost to space. What we're going to be doing is studying the top of the atmosphere as a way of understanding the extent to which stripping of gas out of the atmosphere to space may have been the driving mechanism behind climate change. We study the top of the atmosphere because that's the place where the gas that is escaping resides, and it's a conduit through which the gas has to traverse as it goes from the lower atmosphere to the top, where it can be stripped away by the solar wind or by other processes. We think we understand a lot about processes that may have occurred on Mars to remove the gas, but we really don't know. We think we have an idea of many processes that may have operated, and this next video shows one example of the ability of the solar wind to strip gas away. The colors represent the top of the atmosphere, the arrows represent the solar wind, and you can see the gas dynamically being stripped off and removed from the Mars environment. The question is whether over long periods of time, this process or any of the other processes that are operating have been responsible for removing a lot of the gas. This is the major question that we want to address. In order to do this science, we want to understand the driving forces, that is the energy that comes in from the sun, from the solar wind, and how the upper atmosphere responds and how the response leads to escape of gas out the top. We measure these things today, even though the processes we're interested in operated billions of years ago. By looking today, we can understand the processes and how they operated and extrapolate backwards in time. This next graphic shows the instruments that will be making the measurements on the MAVEN spacecraft. The ones in the upper left in the yellow box make the measurements that are relevant to the energy input from the sun, the energy that's driving the system. The ones in the red box in the lower left tell us about ion-related processes and escape processes. The two instruments in the lower right in the blue box tell us about neutrals and ions, plus they give us clues to the long-term evolution. With these instruments, we should be able to get enough measurements to tell us what happened to the water, what happened to the carbon dioxide. Now, since nothing is never easy, we have our own cross to bear here. Comet Siding Spring arrives at Mars about 4 weeks after MAVEN arrives at Mars. And if we can look at this next graphic, this video shows the path of MAVEN seen in the top part of the screen on its approach to Mars. Coming in from the lower left, you can see Siding Spring. It was discovered early last year. It's going to miss it's going to miss Mars by about 130,000 kilometers. I'm told that the odds of having an approach that close to Mars are about 1 in a million years. So it's really luck that we get the opportunity here. We thought that there might be a significant risk to the spacecraft from dust released from the comet. Detailed modeling shows us that the risk is relatively minimal, though. So although we'll be taking precautions to make sure that we minimize the risk, even from what it is, we don't think that there's any real significant risk. However, we are going to take advantage of this bonus opportunity to do science, and we'll be making observations of the comet itself and of the Mars upper atmosphere before and after the comet arrives. We have the delight, if you will, that the upper atmosphere is where the effects of the comet have the greatest effect, where we'll see what happens as gas and dust hits the upper atmosphere, if there is any dust to hit it. So we should learn a lot about the upper atmosphere from this natural experiment, watching the perturbation from the impact of gas and dust, and we're hoping to learn about the comet as well. Now, this requires us to first make sure that we can do the observations in a safe manner. After all, this is a Mars mission, and the Mars science to come has to come first. We're going to make sure we can do this and maintain the spacecraft and the instruments in a safe and healthy state. The MAVEN mission is a mission of discovery, trying to learn about the upper atmosphere of Mars, the history of the climate, and the potential for life. We're almost there. We have one big step ahead of us, and then we can get on with this. In order to tell you about the process of getting there, I'll turn this over to David Mitchell, the project manager.
Thank you, Bruce. It's really a great week as we're approaching Mars, but I'm actually going to take you back in time a little bit. We're going to go back to November 18th of 2013, where we launched on board an Atlas V. I'd ask that the video roll, please. And we actually launched on the very first day at the opening of the window, and it's critically important given the 20-day launch period that we have for such a mission. So beautiful liftoff. Great delivery by the United Launch Alliance and Kennedy Space Center and the U.S. Air Force and their partnerships to get us to where we're headed right now. So what you're seeing now is first stage separation, then the fairing separation, and then about an hour after liftoff, we separated from the Centaur second stage. A big moment at that point in time was deploying the solar arrays, as you see here, when we could confirm power positive and we were on our way to Mars. In fact, all the energy we needed to get to Mars was done by virtue of the launch vehicle. So it was just a great ride as we went. And you'll see here again another, as we're showing the path that MAVEN has been taking the past 10 months on its way to Mars. And then in a couple of minutes, I'll turn it over to Guy Betelgeuse, and he'll talk about the next few days ahead. But this just shows the approach getting to Mars. So that all went very smoothly, but again, going back in time over the last 10 months, what we've been up to, there's been a number of things. So certainly we checked out all the spacecraft systems, we checked out all the payloads. About 60 days or so ago, we turned off all the payloads in advance of the Mars orbit insertion, what's called a moratorium. So the system is very quiet at this point, and it's just the essential systems that are operating right now. And everything is checked out in it, I'll say, in its pre-deployed state. Guy will talk about some of the deployments to come in October, but real happy with how the overall spacecraft and payload systems have been operating, and it's really, kudos to the design, build, and the test that was done in advance of the launch and the journey along the way. So at this point, we're about 218 million kilometers from Earth, about 1.2 million kilometers from Mars, and traveling at a velocity of 81,000 kilometers per hour. As MAVEN is approaching Mars as of today, the view of Mars from MAVEN, if it was looking at it, would be roughly the size of a baseball, about 52 feet away. So essentially, as a pitcher is throwing his baseball from the mound at a Major League Baseball ballpark to home plate, about that distance. And so Mars is really growing right now as we approach, just 4 days away. So so far, so good on that front. What we also want to mention that there was a series of planned trajectory correction maneuvers that we did get a really nice departure with the Atlas vehicle, but then we have 4 planned trajectory correction maneuvers on its way to Mars. The first one was conducted December 3rd, and it was a 37.8 second burn using, importantly, the 6 main engines. And these engines are the ones that are going to be used Sunday night for the Mars orbit insertion. So it was not only essential to use for that first TCM, but also a great check and confidence builder that the engines and the whole system is behaving as expected. Then on February 26th, we had a second smaller burn, which was approximately 18.7 seconds, and these were with the smaller thrusters and to really align it right on its path to Mars. And we had, over the summer, scheduled TCM 3 and 4 that were both canceled. Canceled because we're on such a good track flight path to Mars that they weren't necessary. Now we did, in addition to the spacecraft team and the project, we worked closely with the navigation team, with an independent group called the Navigation Advisory Group out at the Jet Propulsion Lab, to make sure, looking at all the data and the different models, that yes, in fact, we were on the right path and there was no need for additional correction maneuvers. So really going well at this point. I'll also say that in these 10 months of flying, the flight ops team has been doing great. We've also had a series of rehearsals and readiness reviews for the big event this coming Sunday night. So we've had a series of those, and the team executed very well. So it's been great. I'm really happy how everything is coming together. The team and all the elements, and when I say all the elements, we're talking literally around the world when you count the Deep Space Network that will be communicating with MAVEN on the day of the Mars orbit insertion. We're all ready for September 21st, and everybody's excited and ready to go. The last thing I want to say is, as we approach, we're on the verge of science, the real science phase of the mission. And it's been an 11-year journey. When I consider the folks like the gentleman to my right, Bruce Chakosky from the University of Colorado, having hatched this idea of a MAVEN with a couple of other scientists from Berkeley way back in 2003, and then the growing team as we moved along through the development to the point we are today. And I'm really excited to be us collectively delivering here for the science to come. So I know Lisa mentioned the partnership, but I want to say it one more time. Kudos to the team, University of Colorado, Goddard Space Flight Center, Lockheed Martin, Berkeley, and Jet Propulsion Lab on the journey so far. And there is big events to come, no doubt, but the team has executed well, and I believe we're well prepared for Sunday night. So with that, I'll turn it over to Guy.
Thanks, Dave. It's pretty exciting. After all the team rehearsals, after all the hundreds of tests that we've run, after all the reviews we've sat through, we're finally going to go into orbit around Mars. We're conducting operations from our mission support area at the Lockheed Martin facility in Denver, Colorado, while the navigation team at the Jet Propulsion Lab in Pasadena, California, is tracking the trajectory of the spacecraft, monitoring its position and its velocity to make sure that the spacecraft is headed to the exact position it needs to for us to safely go into orbit. We loaded the final MOI instructions yesterday. All of the files are now on board, and the commands will execute according to the onboard clock. So there's actually nothing that the team needs to do. The spacecraft will execute all of those on its own. The burn itself will start Sunday night at 9:37 Eastern Time. Now keep in mind it takes 12 and a half minutes for the radio signals to travel all the way from Mars to the Earth. so we won't actually see the start of the burn until approximately 9:50. So let's go ahead and roll the video. So here you see the spacecraft approaching Mars. It's going to orient itself to get the main engines pointed in the right direction, and then at the right time, we will light up the 670 Newton main engines. Now we're coming in at 4,700 meters per second, and we've got accelerometers on board that will detect when we've changed our velocity by 1,230 meters per second. At that point, they'll shut off the burn, and that'll be approximately 33 minutes after the burn start. That should capture us into the Mars gravity well, into a 35-hour elliptical orbit with a periapsis altitude of 380 kilometers and an apoapsis altitude of 44,600 kilometers. At that point, we'll be ready to go into our next phase. We call this our transition phase because it'll be a 6-week period where we will be getting the spacecraft all configured and ready to start science mapping. A major portion of this time will be devoted to taking this large capture orbit and reducing it down to our science orbit. So this 35-hour capture orbit will be reduced down to 4.5 hours with an apoapsis altitude of 6,200 kilometers and a periapsis altitude of approximately 150 kilometers. We will also then do a series of instrument deployments. So let's go ahead and roll the next video. So here you see the first one we're going to do is we're going to deploy our 7-meter long twin Langmuir probe and waves antennas. And then we're going to deploy a boom that contains our solar wind electron analyzer instrument. And then the final deployment is our articulated payload platform. Basically, this is a platform that contains the static, NGIMS, and IUVS instruments. And it's set with gimbals so that we can actually articulate this platform to point those instruments into desired directions as we travel around our orbit around the planet. Another activity we're going to do is, as Lisa mentioned, we do contain a relay communications package on board. And so we're going to test this out by actually talking to the Curiosity rover on the surface of Mars. As part of the transition phase, we will make sure that all the science instruments are turned back on and checked out to make sure that they're all good to go to start returning science data. We're anxious to get everything going. As Dave said, it's been a long road from the very start of considering this, and now we're very close to actually getting in and returning the science data that Bruce and the rest of his science team are anxiously waiting for. So now I'm going to turn it back to Bruce.
Thanks, Guy. MAVEN is a science mission, and we're really excited about the science we're going to do. It's been a lot of effort from hundreds of people to get here to propose the mission, to design it, build it, test it, and did I say test it? To make sure that we're going to be successful when we get to Mars. The team is ready, the spacecraft is ready, we're go for Mars orbit insertion, and then on to science. Dwayne, back to you.
Thank you, Bruce. Okay, what we're going to do here, there's a lot of buzz worldwide on social media, so we're going to go to the social media questions first, and we'll see. We have some folks on the phone lines, and then before we close out, we'll go back to social media. So I want to welcome a new member to the NASA team that's going to tell us what's on the Twitterverse here, Kyle Nero, who's joined us. Kyle, what's going on Twitter?
Thank you, Dwayne. The first question is from North Carolina Space Grant, and they would like to know what education outreach opportunities are planned for the MAVEN project to share science results with the public, such as schools.
We have a vigorous education and outreach program. We're trying to get the word out as best we can through a lot of different channels, including social media, the web. We're also engaging directly into schools through K-12 programs. We're working with planetariums. We're trying to get the word out. If there are ways that we're missing, please let us know, and we will add on to those.
Okay, and again, submit your questions on #AskNASA. And Kyle, you got another one for us?
Yes, I do. It is from Harrison Royce. He wants to know, when will the outcome or success be known?
Very quickly after the orbit insertion burn, we'll know if we've been successful in getting into orbit. We should have a preliminary answer within just a few minutes after the end of the burn. So that will be close to 10:30 p.m. Eastern Time. It'll take a couple of hours of tracking in order to get the final orbit to really understand what orbit we're in and what we need to do to ensure the safety of the spacecraft. If we need to, we can do our first orbit trim maneuver early Monday morning. But we should know within just a few minutes of the end of the burn.
Okay, let's see. We'll go back and see if we have any on the phone, but I do have a question here from one of the space.com folks to talk about the science, or why is it important to understand what has happened to the Martian atmosphere?
One of the really overarching questions about Mars is whether there was ever life, what the history of life has been. Life by itself is not easy to identify, is not easy to understand, and we're trying to understand the context in which life might have existed. Any life on Mars interacts with its planetary environment. We need to know what that environment is and how it's evolved over time. MAVEN is about looking at the history of the atmosphere in order to understand the history of that environment. So it's really telling us the boundary conditions that surround the potential for life. By understanding the processes by which the atmosphere changed, we're learning about the history of the habitability of Mars. And by looking at Mars relative to Earth and Venus, we're learning about the nature of planets and the history of atmospheres in general, with the discovery of planets around other stars. This lets us extrapolate beyond our own solar system to the history of planets, the potential for life in the galaxy at large.
Okay, we're going to take a few calls now on the phone line, and let's start with Mike Belfour from Popular Mechanics. Mike?
Hi there. Thanks for having this conference. I'm wondering what advantage the relay function will provide for spacecraft on the ground.
Thanks. That's a great question. So our rovers and landers on the surface of Mars actually send nearly all of their data back through the orbiters that are going around Mars. They send the data to the orbiters, and the orbiters use their larger antennas to relay that data back to Earth. And in fact, every NASA orbiter that goes to Mars will carry some sort of communications payload to provide that capability. MAVEN has a relay payload on it, as we noted, and would be an emergency backup if needed, but is intended to provide more regular relay services later after its primary science mission.
Okay, let's see. Let's go to Joe Palka. Joe? Joe Palka from NPR, are we there? Okay.
What is the low-hanging fruit from this mission? Is there something that you're going to be able to pick up fairly quickly, or is it going to be something that the scientific results will emerge over time? And approximately how long will it take to start seeing some of the first scientific results?
We're going to begin taking science measurements right away once the spacecraft is commissioned, so early November. At that time, though, it'll still take us a while to understand the calibration of the instruments and to build up enough measurements from the instruments to understand what's going on in the atmosphere. This is different from some of the rovers and some of the orbiters where images start to come out right away that can be interpreted, where you can begin the interpretation. We think that it'll take about several months before we really begin to understand what the data are telling us and what the preliminary conclusions will be. Our plan is to get some of the early data out as quickly as possible and begin talking about the characteristics of the upper atmosphere, the ionosphere, the interactions with the solar wind. But in terms of beginning to get results on how has the atmosphere evolved, how much gas has been lost through the atmosphere over time, we think about the 3-month mark is when we'll be able to start getting those results out.
Okay, before we take another question or two from the phone, we're going to go back to social media. Again, keep those questions coming in at #AskNASA. And Kyle, you got another one for us?
Yes. This is from 7 on 6. He would like to know what happens to MAVEN in the long run and how long does it last?
Take that? Sure. The MAVEN mission is designed to be in one Earth year primary science mission. However, all things going well, we should have enough fuel on board to last many years beyond that. And so at that point, we'll turn it back to Lisa and NASA, assuming things are going well after 1 year, and politely come back and ask them for an extended mission.
Okay. Next on the phone line, Irene from Reuters. Irene, are you there?
For Jim Green. Just was wondering if you could tell us anything about efforts to coordinate any science studies between MAVEN and the rest of the Mars orbiters and landers with India's MAVEN spacecraft. Thanks.
Yes, that's a great question. And indeed, both India and the Indian Space Research Organization and NASA are really quite interested in cooperating and correlating data sets. So I think we'll see as both spacecraft get into orbit and the science teams begin to understand their data, those opportunities will open up. So our plan is to pursue those at the right time, and we've started that discussion now.
Let me add on to that briefly that the European Space Agency Mars Express mission is also making measurements that are relevant to the upper atmosphere. We've begun discussions with them about how to coordinate collection of data and to jointly analyze data in order to bring all of the instruments together. And since we've begun talking with the international partners, we've also actually started talking with the US partners, with the Mars Reconnaissance Orbiter, to make sure that we bring their data into this and really can get the best benefit from all of the measurements we're making at Mars.
The next call is from Pete Spots from the Christian Science Monitor. Pete?
Thank you very much. Thanks for doing this. This, I think, is for Bruce. With the comet flyby, what are you folks going to be looking for? If you could be a little more specific about that. I don't know if any modeling studies have given you, leads on what to look for, or just. But it would be interesting to see what you folks will be keeping your eye out.
We'll be doing a couple of things. We've got 5 days of observations planned, basically 3 before and 2 after the closest approach of the comet. Prior to the comet, we'll be looking first at the comet itself using our imaging ultraviolet spectrograph. This allows us to map the composition of the coma by looking at emission lines from different elements. The ultraviolet is the right wavelength to be making these observations. So with the ability to image the whole comet as it's getting closer, we should have some pretty spectacular results. In terms of looking at the upper atmosphere, we'll do 2 days before, 2 days afterwards. Beforehand, we're looking to just see what the composition and structure are and then see what the effects are. We expect that 2 things can happen. If there's a significant amount of dust that hits the upper atmosphere, we'll see increases in the temperature of the upper atmosphere, and that will manifest itself, among other ways, as an extension of the atmosphere. You heat it up and it'll expand. In addition, the water from the comet that hits the upper atmosphere will begin to populate it with an extra set of molecules, and we might see that as an increase in the hydrogen abundance in the upper atmosphere. What we're going to do is look at this perturbation with the addition of energy and matter, and then see how long it takes to decay away. And that'll tell us about the physical processes that are operating in the upper atmosphere today.
Okay, it's my understanding there are no more questions on the phone line, and what that tells me after doing so many press conferences over the years, that all systems are go, and that the participants here have explained things so well that it is just fantastic. So what I'm going to do for the television audience here is I'm going to ask each participant to give some personal thoughts on what this mission means and its impact and its purpose and how it's going to be a part of the agency's journey to Mars. Lisa, first.
Well, thank you, Dwayne, for that opportunity to give my own view on what MAVEN means to NASA, to the Mars program, and to those folks who are watching. MAVEN, as Bruce alluded to, is part of a long-term strategy. We started in the early 2000s with a follow the water strategy, and there have been jokes over time about NASA has found water on Mars again. But in fact, it has been a very short time that we understood there was persistent liquid water on the surface of Mars. And we have found ample evidence with our orbiters and our rovers and the Phoenix lander that that was the case all over the planet. Well, as Bruce mentioned, if the water is gone, where did it go? And the atmosphere at Mars now is less than 1% of that of Earth. Where did that go? And the ability to understand how that potentially habitable environment, as evidenced by Curiosity's discoveries in ancient stream beds at Gale Crater, the implications for habitable environments and their evolution are enormous and require this piece of information to put that story together. So I'm extremely excited to keep turning pages in the mystery novel that is Mars.
Bruce?
I've been working on Mars research for my entire career, going back to the mid-1970s with the Viking spacecraft. And one of the things I've observed is every time we send a spacecraft to Mars with new instruments that are making measurements we haven't made, we discover a new planet. We're making fundamental discoveries every time we go. And I'm hoping that MAVEN will continue that trend. We're really looking at a part of the Mars environment system that we haven't explored in detail. Previous spacecraft have made measurements. We've learned a lot about the upper atmosphere, but we haven't been able to put the whole end-to-end picture together. So I'm hoping that MAVEN will be a mission of discovery, that almost everything we observe will lead us to fundamental new insights about the Mars environment today and how it's evolved over time. As we do this, I've been focused for the last 11 years, as Dave said, on MAVEN, and I'll be honest, I've sort of lost track of where the rest of the program is going, so I'm not even going to try to integrate it. I've had my head down, narrowly focused on the MAVEN mission.
Roger that. David?
Yeah, I'm going to give a response that's more personal, and that is it's a great journey working with a team that we've been a part of all these years, and it's the people, it's the families, and to be there, you know, everybody working together, and I really mean that with the partnership we've had. You know, I wake up on a Monday morning, and it's not a typical Monday morning. I'm excited to come into work with this group. I feel really lucky to be a part of this. It's really been special. I'll also say, you know, all of us and many out there, we go out to the classrooms and, you know, talk about MAVEN and talk about other missions that we've been working on, and to see the look in the kids' eyes and inspire the next generation, truly. I mean, that's a big part to me personally, and so I'm excited about that. And of course, going to Mars. I mean, you think about that as a kid, and just how cool is that to work on something that eventually is flying to Mars and is now 4 days away. So it's just such a great thing to work with this team and be at the place we're at right now.
Guy?
Well, I'm going to echo that. I mean, I remember being 7 years old and running around the yard and pretending I was arriving at a new planet and was going to go explore it. This is why I got into engineering, is these kind of things. I mean, we're going to Mars. And we're continuing an investigation, and I think that really kind of, you know, is something kind of special a lot of people don't realize is how this mission really builds on all the investigations that have come before it. There's been a series of Mars spacecraft, and at Lockheed Martin, we've been fortunate enough to partner with NASA during this exploration, and so we've been able to use that. We've got Mars Odyssey around orbit in Mars right now, and we based the design on Mars Reconnaissance Orbiter on Mars Odyssey, and then we based the design of MAVEN on Mars Reconnaissance Orbiter. And so we're really not only able to build on the science, but we're able to build on the engineering as well. And so kind of that wealth of experience it's really given us a lot of confidence going forward into what I expect to be a very successful mission.
Well, thank you all for your comments, and that's going to do it for us. I want to remind folks that you can get all of the updates on the mission at www.nasa.gov/MAVEN. Live coverage on NASA television will begin at 9:30 Eastern Time. Live coverage Sunday, September 21st. Also on the NASA website at www.nasa.gov. Ladies and gentlemen, all systems are go for MAVEN's orbit insertion September 21. Join us, join the conversation. Thanks for joining us, and the journey to Mars continues.